Hi, I'm Kevin Drinkall.
Hi, and I'm Michel Nicolai, and we welcome you to Zyzone Networks podcast.
We've been in the network industry for over 15 years, and in these podcasts we want to try and untangle the world of networking, debunk some of those myths, explain some real-world examples along the way, to help you make better choices about selecting the right tech, product, and even help you guys build faster, more reliable, scalable networks, or just to keep your kids happy at home. Well, welcome back for another podcast, and in today's podcast we're going to talk about why do we need smart antenna?
Wow, yeah, that's a good topic. But before we move into that, maybe we should start with the basics. And who can we invite best to tell something more about smart antenna?
Well, Hugh Simpson has decided to join us again.
It's
So
great
welcome, Hugh.
Yeah, it's great to be back, guys.
So, smart antenna. I mean, there's quite a lot to talk about. And I think with all of the kind of different technology advancing, I think it's really important that we cover this as a topic and explain why. And I think you're the guy to do it, right?
Yeah, no, and before we get really into the depths of smart antennas and why do we need them and what they are, etc., I think we need to go right back to the basics, guys. How do you think about that? Let's go right back to what is an antenna.
Yeah, let's talk about some like the differences between omni and directional antennas, and let's talk around those parts and maybe cover some of the frequencies and about all that sort of, why we can use it indoor, why we can't use it outdoor, and that sort of topic, just to cover the kind of basics so people we build up a picture first, right? So
Yeah, but people don't see it from the outside, what kind of antennas we are using nowadays, because it's all covered into the box itself. So I think it's good that we do some explanation on that one as well.
Yeah, no, if we go back in time a bit, these horrible external antennas, they were everywhere. They were like spiders, multiple antennas. And you see some of these gaming routers, right? They look like spiders more than they actually do look like anything else with the amount of antenna.
People love them.
Apart from my wife, who used to keep knocking them down, right? And we'll talk about that. That's a great one. But antenna design has really come a long, long way. So if we go right back to the basics, it literally was a piece of wire at the right length, and that was it. There was nothing smart about it. There was nothing clever. It was, barely a wire that was in a piece of plastic, etc. And you hopefully pointed it in the right direction.
So what are the differences in the antennas then? I mean, we have the omni. I mean, we know obviously ourselves, right? But maybe we need to explain it about why omnidirectional became the kind of standard, right? And what the benefit of that is, and the disadvantages as well at the same time.
Yeah,
right?
so omnis are your standard antenna. They've been around a long time, etc. And we have to understand what the omni antenna is. It basically, the easiest way to describe that is it transmits 360 degrees around the vertical of the antenna. So it kind of goes out like a big fat donut, right? Kind of signal from that antenna. And again, it's all important to understand how that antenna, or which way that antenna is pointing, right? Because, it radiates out of it. So if you have that antenna in the horizontal, for instance, it's that donut shape is going to go up and down. It's not going to go left and right. So again, pointing those antennas is all important. And many times I've seen that, simple signals and simple poor wireless has been fixed by which way you have the antennas. I joked about it, my wife knocking them down all the time because she didn't like them up. Absolutely. That changes the dynamics of the wireless. Again, another important factor about omnidirectional is the fact that, if you increase the power, so, hey, we want the biggest and greatest antenna, etc. Actually, by increasing the power of the antenna, actually flattens that donut. So it then becomes like a thin pancake, using the food terminology still. And again, you can mount the antennas too high, because if it's a pancake, it's not coming down. So again, we've seen those scenarios. So it's really important. The other antenna you talked about is directional, right? These are great, fantastic in the right scenarios. And antennas have come a long way from the basic designs. And again, panel antennas or directional antennas have a a wide range of usage in different scenarios. Again, in the classic one where we mainly use or have used directional is in warehousing, for instance, and pointing down aisles and racking, etc. It's commonly used, and it's the best way, or used to be the best way of getting the signal down.
I mean, when you're talking about the different types, of course, that every country has has a power requirement, right? A maximum power anyway, right? So
yeah. Again, I talked about that. We all want the greatest power, etc. There are still standards we have to stick by, right?
Absolutely.
We can't just take the access point and slap on a big antenna, because what the antenna does is it amplifies that signal, right?
That's the gain that we see on the specification of the antenna, isn't it?
Yeah, exactly. So it amplifies it, and we've got laws to abide by, right?
Absolutely. So when you think about Omni, which is a 360 degrees around the device, right? It can only use the same amount of power as a directional, theoretically.
Correct.
So that means you're spreading the signal, right? So it has not as far to go. Whereas when you're narrowing the beam and point it in one direction, then the benefits of doing that, obviously you reduce the coverage, but you focus the energy.
Absolutely. And we can cover kilometers distance with a directional antenna, right? So again, I talked about a scenario in a warehouse, but if you use it on the outdoor environment, we can point-to-point links with directional antennas over long distances.
So when we talk about the different, obviously, antenna types, there's also the frequencies in which we work in, right? And today's standard frequencies are 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. And we talked a little bit there about using directional antennas outside, but 6 gigahertz outside.
Unfortunately, as it stands today, it is a no-no. Okay, and even putting it in your external casing, etc., that we have as an accessory in Zeisel, you still can't do it. Okay, that's unfortunately one of the regulations with allowing 6 gigahertz to be used in the Wi-Fi space, is that we can't use it in anything but very low power and indoors only. And I got asked a question the other day: can we put it on a stadium? Because in a stadium you're undercover. Are you indoors?
So physically, yes, we can do it, but is it allowed? No.
Yeah.
That's the thing.
And in a stadium, by the way, the answer is no, you can't, even under the,
But also I remember that with antennas, can I use any antenna on every frequency, or is there any regulation on that one?
That's a good question, actually. And what we found recently with people trying to upgrade modules within laptops and PCs, etc., and for Wi-Fi, right? So we've now got this new 6 gig, and we've had it for Wi-Fi 6E, and now we've got it for Wi-Fi 7. They've just upgraded the module, just expecting it to work with the same antennas. Actually, there is a difference. Okay, there is a difference in the 2.4, 5, and 6 gigahertz antennas, and making sure you match the right antenna to the right frequency is all important. 2.4 and 5, it's roughly double the, or half the size, etc., depending which way you look at it. So they pretty much match. So you often find antennas which are 2.4 and 5 gigahertz. Right? They're the same antenna because it's roughly half the amplitude. 6 isn't always that easy.
But is it you really see it, or is it better if you take an antenna that is dedicated 2.4? Is it really an advantage, or you would say take a universal one, or what is your feedback on that?
You would hopefully, if you took a dedicated 2.4 and a dedicated 5 and a dedicated 6, for instance, if you could put external antennas on 6, you would hope that actually they are really tuned to that frequency. The understanding of antennas, the understanding of those frequencies, of those amplitudes, and is really gone a long way since the simple wire, right? But no, mixing the 2.4 and the 5 into a standard antenna is absolutely fine.
I think now we have the 6, right? It's well, I would say much more complicated in its approach and design. So I think that inside a device, I mean, in fact, I think you'll find you won't actually find external antennas for 6 GHz.
No, you won't. Not at the moment.
Because it does, you're not allowed to use the 6.
Exactly. So, and I think when you're adding antennas, you also need to consider how you measure the power output as well, because you need to control that, right? So whilst the device will physically output, a certain amount of what we call dBm, which is how we measure power output, when you add an antenna, you're responsible for making that calculation about how the total power is in the legal limit as well, right?
Yeah.
So it's really important to kind of carry that part as well. So I can't stress that enough. If you're using external antennas, make sure you measure or you understand the total.
And you match it, right? And you understand it. And things like lightning,
Yeah, exactly. Yeah.
conductors and stuff like this, and cables and the type of cables that you're using, all minus those numbers, etc. So therefore, you've got to put all that into the calculation.
So we mentioned there a little bit about dBm. Well, I did anyway. So, but this is a mechanism. This is how we measure Wi-Fi. We covered a little bit about measuring Wi-Fi in one of our other podcasts. But what is good and what's bad? I mean, we did mention this in one of our other podcasts, but because we're in this one, right? Let's talk about that right now. So, what's good and what's bad in Wi-Fi?
It's a really great question on what's good and what's bad about the dBm. It's all about keeping within those legal limits, first of all. And then we've got to look at other things like floor, the noise, etc., on the floor, etc., and the signal to noise ratios, etc., that are out there. They're all important to actually understand and get the best signal to your client. Again, your client will see and hear that signal differently, right? So if you have a laptop, you have a phone, you have an iPad, you have the worst ones are those warehouse guns, etc. They are by far the worst devices to receive the signal. And actually that power output from the access point is all important, right? And we talk about different levels, right? So, what is usable, what is not usable, -80, -50, etc. Again, that is all down to the client. Okay, and how they receive that signal, right? Whether they can communicate, how much data they're expecting to communicate. So I talk about the handguns, right? They're really bad, but actually they don't transmit a lot of data. So actually connectivity is the important part. What signal they're connecting at, what power they're receiving is all important, and vice versa, what power they're transmitting at as well to be received by the access point. Remember, it's two ways.
I think when we talk about that as well, we should mention about the sensitivity, right? Because whilst you can transmit on an access point, also the way to listen back as well, right, is really important.
Absolutely, and that sensitivity, takes into account the noise level of, the standard noise level within Wi-Fi. There is always a noise out there within the frequency. So actually the sensitivity of the radio that's listening back, it's like making your ears bigger, right? You've got 2 or 4 antennas, etc., but actually making them bigger, making them more sensitive to the noise and the signal that's coming back, that really helps that return signal.
Yeah, but especially I think for battery powered devices that are not as powerful to send a signal back at the same strength as the access point, it's really helpful that you have a good listener as an access point that can take all the bits and pieces that they're receiving from the mobile device onto the access point. I think that's really
IoT,
important.
Yeah, absolutely. IoT devices, and I think that's one of Zyzel's strengths as well in our access points, is that we have a really high sensitivity rate in the higher end access points.
Yeah, but not only IoT. The majority of people are working with tablets and mobile phones. Don't think that they have the same capability of sending the data back as that the access point is delivering it to that client. So it's really important that the access point is a really good listener in this case.
Yeah, and as Kev said, just to reiterate that point, Zyzel have some of the best sensitivity ratings out there, right? So, our design and our Wi-Fi first process of creating our wireless access points is key, right? You know, it's a great strength that maybe isn't always seen and always understood, etc.
No, I mean, it's always, I mean, let's be honest, everybody eventually can make extremely fast speeds. Reliability is actually king, I think, out of everything. When you talk about wireless connectivity, no one ever remembers the fast speeds. They always complain about how reliable it is, right?
Absolutely.
And I think when you look at the way that we design access points, you know, from not just the sensitivity level, but the way that we shield the components, the higher end components that we use, it makes a big difference. And I mean, it may be 2 or 3 dBm better, but this is
3 dBm is twice as strength, twice as strong as the original signal. So it's a huge difference.
could be the difference between 200 or 300 megabits per second.
100%.
Absolutely, yeah. And, you know, it just really helps the throughput and the performance and the experience of Wi-Fi.
So, I mean, I liken the kind of the way that we build access points and the way that we kind of look at the shielding and everything and how we improve that against, you know, the old tape decks when people turn the power and you end up with a hissing noise in the background, right? The access point itself creates noise. And when we shield the components and use high-end components, we reduce that overhead. And, you know, when we look at other vendors, we can see that they don't do any of that, right? And they already have to get themselves over all that noise to start with before they can even start to listen. So I think when we talk about the sensitivity and all this sort of stuff, we really try to make the experience of the connectivity the core part of our build and design. And I think that's really important from a Zyxel point of view. Another side of that is positioning, where you position the access point, right? It's really key.
Yeah, because most of the access points that not only we are building, but also other manufacturers are built to mount on the ceiling. Yeah.
And why is that?
Yeah. If you put it on the ceiling, normally people are sitting, under the ceiling. So if you put an umbrella on top, then you get the biggest coverage, for the people that work underneath that access point. So it's obvious that you put it on the ceiling.
Yeah, I mean, the design is often designed to be optimized for this condition, right? But in reality, in the real world, it's not always possible to put it on the ceiling, right? There are high ceilings. You lose a lot of signal by the time it gets down to the bottom. There are, you know, buildings that you just simply can't put it on the ceiling for lots of different reasons, whether it's listed or, you know, all sorts of weird and wonderful things. But one of the common mistakes that we do see is that people take a normal access point, a standardized access point, and they put it on the wall. And that just... it doesn't work because
it fits, but it doesn't work.
No, because it is optimized to go from ceiling. So essentially, you pour in signal.
I think we need to take that step back. It's not optimized to work. It still technically works.
Yeah, correct.
It still transmits a signal. It's just not optimized, right?
Still. Maybe we should explain why it's not optimized. Yeah, because yes, we are sending a signal. From the wall into the
ceiling and into the floor. And we're not projecting it. The other reason why we put them on the ceilings is, you know, things get put in front of access points like cabinets, walls get built and everything else gets put around an access point. On the ceiling, it's out of the way. You know, again, on the wall, one of the worst things for Wi-Fi, right, is water. You know, only takes a human being, and we're 80% water, right? Yeah, maybe some of us more, I don't know.
Which is why stadiums are so complicated.
Yeah, absolutely. You know, you put them underneath seats, etc., in stadiums, and hang on a moment, people are sitting on top of them, and therefore you've got to radiate through that first of all, and that person and that water, etc., that's built there.
It's far from optimal.
Far from optimal. It's a really complex design, and
But wait,
but
we have a solution.
I think we have a solution for that.
Oh, we have a couple of solutions actually.
We do. That's right. Yeah. So maybe Hugh, you want to talk about them?
So the first one we have, and we kind of moved around why it's on a ceiling and why we might need to mount it on a wall. And Kevin, you're absolutely right. There are lots and lots of scenarios why we cannot mount them on the ceiling, okay? So we have the dual optimized antenna products in our range, which include the WAX or WAC 610D. So the D is the dual option or dual mode. And we also have the WAX 510 mode as well. So we have a couple of models that are absolutely suitable to be mounted on the wall and you can just flip that configuration over to be dual optimized.
So how's the switching done then? Is it a physical switch or do you do it through software?
No, you do it through the configuration, etc.
Okay.
So yeah, there are other products out there that might do it based upon which direction it's pointed, etc. But no, absolutely, we do it via the configuration. This allows us to be in control of it, right, rather than allowing the device.
So the device can be used either on the ceiling or on the wall, and you can basically select between the two, right?
Correct, yes.
Excellent. I mean, this means that customers can just select one product to meet both scenarios.
Yeah, that's a big advantage. Yeah.
So the other type of product we have is smart antenna, which we mentioned several times up to this.
Well, it's the title of the podcast,
Exactly.
surely.
So why do we need it, Hugh?
And why is it smart?
Yeah,
That's also the question.
Yeah, smart antenna is absolutely fantastic. And it takes all the properties that we talked about with the antenna basics, dual mode, etc., and it takes all of those ingredients and actually delivers the best signal for you. Now, how does it work, I guess, and what is it? It basically takes your client, it listens to where you are and builds a signal pattern, a directional, if you'd like to call it directional, it's not quite, but a directional pattern, antenna pattern for your client. And it's monitoring where you are and how far you are away from the AP, etc. So it's always monitoring, always changing, and it's measuring that. So again, and it's doing that not just for one client, it's doing it for all the clients that are attached to it.
So I think, when we talk about this, I think it's important to understand that typically a normal access point has one radio pattern, basically.
Absolutely. And again, that pattern, you could be one side of that pattern and someone could be the other side of that pattern, or noise could be the other side of that pattern. And you could be interfering potentially with each other, even though you're connected to the same AP. And that degrades the signal, right? That just stops the Wi-Fi from working or being optimal, etc. So it's lowering your throughput. And basically, as we've talked about, it's all about experience, right? We want the best experience.
Absolutely.
But how about if I have multiple clients? Does it work with multiple directional antennas or something? Or how does it work if you have multiple clients?
Absolutely. It's building a pattern for every client that is attached. So every client gets its unique pattern.
So when we're talking about, the difference really in a nutshell is a normal standard access point will have one static antenna. And if you have one of our access points with smart antenna, it will allocate a radio pattern based on where the person is located, how close, how far they are, to optimize the condition for them.
And it's optimizing because, again, it's listening to what noise is around and it's trying to block that signal out, and it's optimizing for that client.
So when we're doing this, I mean, I've obviously, we've all presented this many times, right?
Yeah.
In different areas, and often I'll describe it like when there's interference occurs, it moves it away from the interference. It reallocates the device and access point. It reallocates a radio pattern for that device. When the device is further away, it basically creates a different radio pattern to optimize it for further away, meaning it can increase what we call the DBM. Remember, we mentioned that before, to increase the kind of level it's at, so the modulation, so that its connectivity improves as well, right? And unless anyone wants to add anything else to that, I think that's...
I think you had a good point, because if every client has a dedicated beam, I think the other advantage of smart antenna, we didn't touch it, but also the number of clients we can connect to the same IP is much larger than on a normal access point, because of the efficiency of the beam that we deliver to the client.
And because we're optimizing, and Michelle, you're absolutely right, and we should really mention airtime in this, because we're optimizing, we've got more spare airtime, right? Or we should have, or we can pass more data in that time. So therefore we can absolutely take more clients. And different clients speak at different speeds, etc., and distances that can also have an effect. This just allows the optimization of that.
And it's all done from the access point. So that's why it's called the smart point. So we don't rely on the client or any software, and we don't really care what generation it is. Obviously, you should consider which products are connected, but it doesn't really matter on the what the device is. The access point will take care of this kind of connectivity to optimize it. And as Hugh said, and I think I mentioned before, it's all about the experience to make sure that the quality of connectivity is optimized all the time.
But is it then the case that you just change software and that every access point can work with smart antenna, or is it something special? You need a special device or model to use smart antenna, or you can use any of our devices?
No. We have a unique model. It is a design. The antenna board is unique in our products and is designed purposely for our products, tuned, etc. So again, if you look at our products like the WBE 660S, the S stands for smart antenna. So, right. So, and I mentioned that product, that's our Wi-Fi 7. So is it based on frequency? No, it works across all the frequencies, and it works from, we've introduced it in Wi-Fi 5, 6, 6E and 7 products. So again, the S model or the S number or letter, etc., that sits on the end of our Wi-Fi access point codes dictates whether it's got smart antenna or not.
So it's very easy for customers to understand, to see on the model name what kind of antennas we're using. Yeah, so that's
correct.
Very smart.
I think it's also important to, obviously we have a range of different access points for different scenarios, right? And whichever Wi-Fi standard you're using or however you're deploying, you might want to use a mix of smart antenna and non-smart antenna in your environment. But the idea of smart antenna is to fix problems or optimize the condition. So if you're in a high density environment or a challenging environment, then smart antenna is often what we will just suggest, right? So.
Yeah, absolutely. Again, use the smart antenna in the right way and in the right environment. Again, there ultimately is a benefit to using it. It'd be great to have it everywhere. I'd love that. But again, we've got to find, those high densities, those scenarios, etc., that really utilize it. Early, we talked about warehouses and with directional antennas. We've now got the smart antennas that actually work in that same way, right? So it understands the channel interference, and it builds that antenna pattern for those clients. So it almost works like it's a directional antenna.
So in the end, it really depends on what you're deploying. But as I said, if it's a noisy environment, and when we say noisy, I don't mean like there's, people shouting. I mean like the airwaves are noisy, or there's elements you can't control, or it is a challenging environment, or it's a high density environment, then this is the product to use, right? And that's why it really exists.
So maybe for the audience, maybe we can name some of the scenarios that we typically do this. Kevin, you mentioned warehouses, but I also can name, let's say, restaurants or lobbies where a lot of people come together.
The hospitality for sure is a big
those areas where you've got a lot of noise. For instance, we talked about the warehouse, the directional, high density environments, etc., with lots of people. Okay, but high density can also be with lots of noise around, lots of access points. So if you're in that residential areas, those hospitality with lots of APs in the building, etc., all of that is causing noise. And smart antennas really aim is to kind of reduce that co-interference and give you the best experience possible.
How about conference rooms?
Well, to be honest with you, any shared resource building where there's a large office where you can't control Wi-Fi on the floor above and below, it's perfect. You just, and less effort for our engineers, right? Because actually it will do a lot of the work for you. If it doesn't work with a smart antenna, it ain't going to work. So you will really struggle, and also will help you with power output as well. A lot of people trying to do power management, and with smart antenna, it will actually assist in this process as well. So a lot of automatic power management in APs can be very complicated and very it ends up with a lot of problems, right?
Yeah,
Problematic.
it's more trouble than it's actually worth. And, yes, it fixes certain scenarios and it works wonderfully when it works, but when it doesn't, it's really painful.
So, and for us, to be honest with you, when we use smart antenna, it's become the kind of fix. We don't
absolutely.
need to do, we can leave the power management to the device and actually let the smart antenna do the workload for us. So I think we're coming to a kind of an end. But what I would say is, what about the things we need to be aware of? What things do we need to think?
This is a great one, actually, because when smart antenna first came out, you get it out of the box, you put it up, and we try to do a survey with it, right? And we walk around, and it wasn't that great. It wasn't. Hang on a moment. You promised us the world, right? You've promised us the greatest product, right?
Great coverage.
Great coverage.
In fact, I remember you saying those exact same words.
And it really wasn't. Okay, so one of the things is surveying. If we're going to survey with smart antenna, you've got to make sure that you are connected to the AP, right? Because the pattern and the optimization and the ability of the smart antenna only works with connected clients. So it will push out a standard pattern for the beacons and for the management frames and the probes. And then once you've connected, once you've associated and authorized, etc., then you get your optimized antenna pattern, right, assigned to you, and then the world's wonderful. So yeah, just be aware when you're surveying these devices, make sure that you are absolutely connected to it.
Yeah, when you connect, you start, don't you? You sort of modulate, and then it works out. Oh, then it improves and allocates a radio pattern. So you have this, even when it uses a mix of bands, right, where it's using 2.4 to connect, and then it moves you to 5, and then it improves the modulation by allocating this radio pattern. So phenomenal technology. I think it's underrated in many cases, right? So the other thing, I think, old devices.
It's independent about the technology you're using. Yeah, it doesn't matter if your device is AX or AC or it works independently.
You just saw me kind of yawn at that. Yeah, unfortunately, it's one of those things that we can't be in control of it, right? We're not always. When we're in a public environment, when you're in those conference places, where all of these high density environments, which again. Yeah, you'd love to be in control and you'd love to design. You can't be, unfortunately. So absolutely, Michelle, it works with all clients of all generations, right? There are pros and cons about having them connected and all the rest of it. But yeah, absolutely works with all of them.
So, that's a lot of information to take on from our podcast. And so I think we should kind of round up there. So, Hugh, thank you very much for all this information.
No, and hopefully you found it useful, guys.
So, yeah.
Yeah, thank you.
All right. Thank you very much.